Hi, everybody. Welcome. Thank you so much for joining us tonight. I'm very happy to introduce my friend and colleague, Tei Carpenter, an invaluable colleague over the years, who is the founder of Agency, an award-winning New York City and Toronto-based architecture and design studio. Tei's practice works on projects at a variety of scales, including buildings, infrastructures, objects, and environments. Tei is currently an assistant professor at the University of Toronto, where she teaches design studios and seminars. Her design and research work has been supported by a number of international organizations, including the New York State Council for the Arts and the BMW Mini. Agency has been honored as a Next Progressives by Architect Magazine, selected as one of the 2018 New Practices New York by the American Institute of Architects, and recently featured in Domus Magazine's list of the best 100 architecture firms. Following Tei's lecture, the discussion will be moderated by Daisy Ames, founding principal of Studio Ames and adjunct assistant professor of architecture at the Cooper Union and at Columbia University GSAPP, where she coordinates the housing lab, leading a team of researchers on the topic of housing at the intersection of climate change. The title of Tei's talk today is Lively Things, with the intention to explore through her recent work the life of materials, infrastructures, and designed elements within larger environmental transformations and within the everyday. In a recent interview for Pinup Magazine, Tei addressed climate change by recalling Albert Einstein's quote, "We can't solve the problems of today with the tools that created those problems." She argued that in order to address climate change, we need new tools and new approaches to effect behavioral change, not new technologies. More and more, she argued, I think we should go back to learn from the elemental and primal means and ways of working, studying the aesthetic and thermal properties of materials like rocks, earth, and even the potential of things like tidal and lunar gravity power. This kind of regression that Carpenter calls for is particularly meaningful today in a transfigured climatic reality of methane clouds, decomposed debris, plastic agglomerates, and dispersed PCBs, namely a reality where materials are distributed in space and time, making the line between animate and inanimate objects an impossible division. Similarly to Jane Bennett's concept of vibrant matter, Lively Things depict how all matter is vibrant and is an actant on other matter, thus endorsing an understanding of the world as a constellation of flows rather than an accumulation of discrete objects. As Jane Bennett argues, the image of dead or inert matter feeds human ego and empowers earth-destroying tendencies by preventing us from detecting and acknowledging a large range of non-human powers and influences that we interact with. Encounters with lively matter chastise in many ways the ultimate fantasy of human mastery, exposing a wider distribution of agency and reshaping the self and its interests. This position, hopefully one that Tei will illustrate in this much anticipated talk, asks architects to investigate the full spectrum of life in all its living systems, materials, and components, as a complex intertwining of overlapping ecologies and the way they unfold in space and time. On that note, I would like to invite Tei Carpenter to take the stage. Thank you so much for joining us, Tei.
Thank you so much, Lydia, for having me. And thank you so much for the kind introduction. I'll go ahead and share my screen. One moment. How's that? It's good. Okay. Great. Well, yeah, thank you so much, Lydia. Such a great colleague and friend. And I'm happy to see you. And Dean Tarhani, thank you so much for the invitation, for having me. And it's really wonderful to see so many familiar faces in the Zoom audience. I wish we could all be joined together, but hopefully sometime soon. as Lydia mentioned, I have a practice called Agency that's based out of Brooklyn. And what I want to do today is I'll just sort of start by setting up a little bit of the background about the practice. We began in 2014, and this is just a selection of some recent work that we've been doing. And for me, I think architecture is about designing spaces and then also spatial systems that envision new ways to engage with and inhabit the world. And I think for us, architecture and thinking architecturally can occur across many scales and also many formats, whether it's the design of buildings, of rooms, infrastructures, or environments. And I hope to share some of that with you today. Recently, we've been focused on residential work and infrastructural installations. And so indeed, the title of my talk today is Lively Things. And Lydia, thank you for hitting the nail on the head with your introduction. I wanted to use Lively Things to discuss some of the recent work and ideas that cross between my research and my practice, particularly as it relates to Lydia's very important lecture series prompt about landing and entanglements. And I think as a sort of brief introduction, Lively Things describes an approach that is a way of seeing the liveliness in inanimate things, for example, in materials and artifacts and animals and plants. And the idea follows from Jane Bennett's work in her book, Vibrant Matter, on the political ecology of things, where she describes how inanimate things have the ability to act and to produce effects, both dramatic and subtle. She argues that it is our ethical task at hand to cultivate the ability to discern non-human vitality and visibility, to become perceptually open to it, as an approach to treating non-humans more carefully, strategically, and more ecologically. And so through this lens of Lively Things, tonight, I'll share with you 5 recent projects that range in scale from an environmental marker project to a preservation project that transforms a building into a park to an interactive infrastructure. And I'll try to set up 3 frameworks that touch on the concept of lively things that I think kind of thread through the work. So those 3 frameworks would be coexistence, material life, and an idea of double duty. And so what I'll do is I'll try to set up those frameworks before talking about the work, and then I'd like to leave some time at the end for some discussion. So this first framework of coexistence, this is an image of a hermit crab living in a soap bottle cap. And I think it highlights this tension between society and nature, which suggests that they're not opposite, but rather increasingly intertwined and codependent with one another. This is a photograph by a great photographer named Manabu Miyazaki. And the image suggests an approach, I think, to sustainability that both mitigates human impact while also admitting to it through new modes of material reuse and also a co-production with nature. So in the 1970s, if architectural responses to the environmental crisis produced iconic works such as this one, Buckminster Fuller and Shoji Sadao's Dome over Manhattan, which is a closed world in which the enclosure insists on a binary condition of society inside, nature outside. Instead, in the practice, I'm interested in how to work with concepts of coexistence and co-production, modes of collaboration, perhaps, working with nature, not against it, designing both for and with multiple species. The second framework that I want to talk about tonight is material life. And so this is a diagram of the Kalundborg Industrial Eco-Park in Denmark. It's known as an industrial ecology, one in which the inputs and the outputs of the system are circular, and exchanges of materials, of energies, of water produce productive overlaps that suggest a kind of metabolic process and really a deep engagement with material life cycles, with waste, and with reuse. I think at the same time, material life as a framework is also about an awareness of materials and the passage of time. And so this is a wood block by Kuniyoshi, and it depicts the Ise Jingu in Japan, which is an ancient shrine. And the image is actually of a festival that occurs every 20 years as part of a ritual of reconstruction of 2 of the buildings and also the bridges that are leading to the complex. And through this continual renewal of the buildings, the knowledge of craft and of skills is passed down across generations, embodying a notion, I think, of maintenance that's tied and linked to the architecture very directly. The last framework I would like to kind of set up is an idea of double duty. And this is a work by one of my favorite artists. She's a Brazilian artist named Renata Lucas. And here she repaves an intersection in Rio de Janeiro by layering the asphalt with plywood, giving this in-between space of the intersection a kind of form of its own. And I think by intervening in the built environment of the city, Lucas focuses on the functions and uses of everyday sites and their infrastructures. But I think at the same time, her work produces an enriched and maybe transformed experience as you move across and through the intersection, while also at the same time raising a consciousness to bring forth these latent systems in the city that we maybe don't notice on an everyday basis. And so in the practice, these three frameworks of coexistence, material life, and double duty run in parallel, and they sometimes converge and occur to different degrees in the projects. And I'll try to illustrate them in the work that I'll show tonight. And I'll look forward to some questions at the end. And so the first project that I'll start with is called Testbed. This project is a winning design for a marker system for radioactive waste storage for the Department of Energy's waste isolation pilot plant, what I'll call the WIP site in Carlsbad, New Mexico. It has a really fascinating history. I came across it through a film by Peter Gallison and Rob Moss called Containment. And the brief for this project asked for a system that could communicate the dangers of nuclear waste that's buried below the surface of the Earth to also deter human entry there for up to 10,000 years. And so this is a task that Peter Gallison, who's a historian of science, has pointed out as both impossible and necessary. And Gallison describes the importance of bringing the invisible into visibility because unseeable abstractions like nuclear waste vanish from national awareness once they're externalized outside of perceptual range. And so this is it's a 16 square mile site in the middle of a desert in New Mexico. It's currently managed by the Department of Energy to maintain both active and passive controls for the whole life of the entire site. And so this is actually an image of that WIP facility. So at this waste isolation pilot plant, along with several others around the world, nuclear waste is disposed of by burying it in a repository that's about 2,000 feet below the surface of the Earth. And the repository itself actually relies on self-sealing geological storage of nuclear waste within the salt formations in the Earth that are actually creeping under pressure. And so eventually the salt collapses and then encapsulates the nuclear waste within the Earth's crust. And so to put the time scale of 10,000 years in context a little bit, it's hard to kind of imagine. The caves of Lascaux are about 25,000 years old. Stonehenge dates to roughly 6,000 years ago. And so here we are about plus 10,000 years. So effectively the marker system has to be durable and also communicate its function to future generations to deter entry until 12,000 AD. So in a sense, it has to be transliteral and has to communicate both with humans and then also other species for up to 10,000 years. So the Department of Energy has actually been looking for a solution to this website since 1993, when it first put together a report that included participation by semioticians, geologists, artists, engineers, and futurists. And these are just a couple examples of some of those proposals, including spikes bursting through grid, which is essentially a Cartesian grid spread over the 16 square miles with granite spikes bursting through. Similarly, a black hole on the bottom, proposed pouring black dyed concrete across the 16 square miles so that it would become so hot, the site would become intolerable and uninhabitable. So as a starting point for our work, we thought about the way in which Anna Singh talks about nature in her book, The Mushroom at the End of the World, describing, kind of in brief, describing an approach that accepts the environment as compromised as a starting point and admits coexistence with contamination and other species as a given to open up new possibilities for design. And so this is our planned projection in 75 years, which would actually be when the Department of Energy transfers their controls from active to passive control and management. And so many of the solutions at the site favor fear tactics to deter entry. Instead, what we proposed is a gridded field of carbon dioxide capturing strategies that produces an active marker system that stores one form of energetic byproduct, which would be the carbon dioxide, above another, which of course is the nuclear waste stored below it. And so this is, of course, a sectional problem. And so the drawing here is a core sample of the project that indicates the geological strata and the notion of this longevity as it relates to the layers of the Earth. So here, in a sense, the drawing tries to collapse both the section, the 2,000 feet below the Earth of the repository, but also collapses, let's say, the past, the references to the past kind of strata to then the future strata of, let's say, technofossils, et cetera, that would then kind of be captured in the Earth across this time span. And so this is a diagram of the array of carbon dioxide capturing strategies and technologies that are in the grid at the very top row. These strategies are ones that mitigate the effects of global warming through decarbonization, including things like direct air capture, which are essentially building scale artificial trees, but also more naturally occurring carbon sequestration technologies, such as in situ mineral sequestration, which happens in minerals such as olivine and then also basalt. So this is the kind of final image of the project, and Testbed is essentially designed as an entropic process. It's a geological earthwork that can transform over a very deep time with a combination of both natural and also artificial formations. And through its continued growth and transformation, these new geologies mark the site as something that's maybe deeply strange, deterring both human and non-human entry and communicating its otherness through fundamental processes. The second project I'll present is called Placapa, a cautionary tale of accumulation, and it's actually also a winning design for a new floating island in the North Pacific subtropical gyre. It's really designed as a cautionary tale in the spirit of Italo Calvino's Invisible Cities and his story of Leonia. And so Calvino describes in Invisible Cities, he describes the city of Leonia, which is really a kind of world that values newness and cleanliness to such an extent that it refashions itself every day, expelling its old used goods in favor of the new. And as the story goes, out of sight of the city's inhabitants, mountains of rubbish surround the city, becoming more indestructible as time passes, a reflection on consumption and discard. And so the island itself is sited in the North Pacific subtropical gyre, which some of you may know better as the Great Pacific Garbage Patch, which is a swirling mass of invisible detritus located in the Pacific Ocean quite near to Hawaii. And it's where the highest density of marine debris and microplastics collect due to the natural wind and then also the ocean currents to form a gyre the size of a small continent. So many people think that it looks like the image on, let's say, on the bottom left, but in fact, the image on the top left is much more of a typical area of the gyre because most of the detritus is actually the subsurface depths, and it's actually mostly comprised of invisible microplastics that harm marine life, actually ingesting it. And so the gyre is one of 5 in the world. And like Leonia, Calvino's city of Leonia, it's really an externality and it exists in this world, but we're not confronted with its effects because it's so distant. But increasingly, these consequences of overconsumption and discard are creeping into our reality. As in, for this example, this is a beach. This is Camilo Beach in Hawaii on the right. And this is actually the beach where plastaglomerate was found, and plastaglomerate being a new rock that's entered into the geological U.S. Geological Survey, which is made mostly of plastic. And so the design of the main island and its archipelago is co-produced over time between nature's ocean currents and human-made waste, not adding any material, but rather over time and with increasing temperatures of the Earth, using the stuff of the gyre to become the materiality and the design palette of the island. This image is a false color density representation that's borrowed from scientific color rendering methods to visualize non-visible parts of a photograph and to make visible the density and the accumulation of plastic waste in the ocean that would otherwise be invisible, and highlight the denser areas in which the archipelago will be formed. And then this is the island. So the island here is seen in a geological plan and section. And the idea is that it's an index of disposability and consumption. So it's coded in color by types of detritus and plastic that's most commonly found by scientists exploring the gyre. So such as something like polyethylene, which is coded in pink, which would be something like plastic bags, foam containers, or nylon, which would be the green, such as fishing nets or ropes, or cellulose acetate, which would be in the blue, so things like cigarette filters or clothing. And the design really uses ocean currents, winds, and density of waste to speculate on form, but maybe an idea of formation over time of these hard plastic escarpments, these sea stacks, et cetera, that are made of both artificial and organic materials kind of simultaneously. As a kind of representational technique and idea, we were looking at geological mapping techniques, such as this geological map of the moon. This is of the Julius Caesar quadrangle of the moon. These drawings, they visualize essentially kind of slow transformations that are occurring to the ground, that occur within these immense scales of space and time. And so the conventions of this drawing, like many terrestrial geological maps, use color to record the relative age of moon rocks. So essentially, this drawing registers what's unseen and links temporality with materiality. And so this is the image of the island, and it's imagined as producing its own extreme ecosystem within the waste, with a new vitality based on a marine food chain adaptation and metabolizing critters such as plastic-eating bacteria, which would have once metabolized the island while binding enzymes help produce the island's ground. So along with the heat effects of coagulating plastic. And so this is the kind of final image. It's an island that grows taller as humans expel more goods while simultaneously becoming more buoyant because of the plastic and the properties of the plastic. So eventually replacing these icebergs as inverted artificial likenesses, continually drifting through the ocean as physical indicators of consumption. So I'm going to switch gears to a project called the Hamilton Gears Reuse Park. This is an unsolicited proposal in Toronto. The starting point for this project actually began by thinking about the enormous amount of new development that's happening in Toronto right now. It's actually the fastest growing city in North America at the moment, with a huge amount of new condos being built in the city. And I was really just curious about what's been happening to the old building stock and the old fabric. So just looking into some of the data, I was curious about the construction, renovation, and demolition waste, specifically its composition. So here on the right, what that actually even means, cardboard, concrete, plastics, metal, drywall, just the kind of pieces of what that means. But also thinking about what happens to all of it with all this new development. Where does all this stuff go? And so in particular, what struck me was that both the renovation and demolition waste, almost 80% is disposed of to landfills versus 20% that's being recycled. So there's this kind of very kind of out of whack data that's happening. And this is not a unique issue to Toronto. I think this is just a kind of contextual observation that I had here. And the jumping off of this project is actually a building I became really fascinated with during my time in Toronto, and it's an existing building called the Hamilton Gears Building. It's about a 20,000 square foot former industrial factory that's built in 1911 in downtown Toronto. It was once home to the Hamilton Gear and Machinery Company starting in 1911, but has since been vacant since 1994. And there have been many potential plans here. The design of a brewery was kind of up for grabs for a little while. Also thinking about redeveloping the site as a kind of promotional corporate event space. Right now it's a sort of co-working space, but nothing really fundamental has come out of it. And so the proposal aims to take advantage of the really unique scale of the space and give a new life to an existing building rather than privatizing it or demolishing it. And at the same time, its aim is to demonstrate how construction, renovation, demolition waste can be reclaimed and maybe revalued by transforming the building into a covered park. And so this is a drawing of a sort of typical building construction material flow. And so if we think about, just roughly the sort of extraction of the materials, the transport of those materials to then processing and manufacture, and then the transport of those building components then to the construction site itself. And then thinking about the life of an average building, let's say, is the operational life is about 50 years. The building is then typically demolished and then sent to landfill. And so more or less, this is a linear process that's outlined here in the drawing with these gray arrows. And instead, what we're thinking about is looking at how the red arrows indicate the possibility for maybe upending the process with an approach to material reclamation for demolition materials that essentially could be a kind of mining of the valuable resources of a building site that are slated for demolition, and to think about how to return these materials back into a building life cycle with strategies of reuse, recycling, or repurposing. And that this cyclical process in turn reduces dependence on raw material extraction and minimizes embodied energy and environmental impact. And so we undertook a series of case studies of historic projects that take on this line of thinking about CRD waste. So one of my favorite is including Alison Peter Smithson's Robin Hood Gardens project in London, which is a social housing project that some of you, I'm sure many of you are familiar with, in which the interior garden or this kind of these grassy mounds were formed from remnants of the construction process, where concrete block was actually crushed and used as aggregate to form the topography rather than sending it away. And so this is the overall kind of diagram of the building construction material flow and how we're conceiving of how to kind of reconfigure that. And so on the top left is the existing Hamilton Gears building in Axon up here. And the idea is that by retaining the building structure and strategically here subtracting the roof, parts of the roof and parts of the walls, parts of the project are designed to be intentionally demolished and recycled at Ontario-based CRD facilities, while parts of it are also strategically subtracted. And so this first red arrow here takes the existing material and reconfigures it to bring it back into the project, including renewing the existing steel frame, also grinding down the existing glass that was no longer kind of up to snuff and was broken to produce a kind of bedding sand, and then also taking some of the excess crushed brick to then make an aggregate fill for kind of topographical landscape. And the second arrow is that any new elements introduced into the scheme itself are actually designed to come from off-site demolition and recycling facilities. So reusing and repurposing materials, for example, such as roof decking for the platforms that I'll talk about in a second, and also steel. And so this is an exploded diagram in the very middle that shows the steel frame that's renewed with new elements that I'll show in a second, and then also this kind of topography at the ground of CRD waste kind of transformed. And so the outcome of the project is a partially covered open park that uses the renewed robust steel frame of the building to suspend stairs and also circulation platforms to move up and through the project, and to also design a kind of suspended landscape that hovers over and immerses the ground plane. And so the CRD materials at the ground plane are reclaimed to produce topographic gardens and mounds for an interactive landscape, both on the exterior and also on the interior of the building. And so here you can see a better view of the suspended stairs and the platforms. And I think in a city like Toronto with such rapid development that's eroding the city's fabric, I think this project really initiates a form of preservation, perhaps, that offers a different value to the site and also a new park typology to maintain and maybe even remix the city's unique histories. I think at the same time, what we are after here is to outline a process of working which can identify subtraction, demolition, reuse, and construction within the same design framework as the sort of design portion of the work itself. So trying to think about it kind of integrated and synthetically as a project itself. These last two projects speak more directly to this idea of double duty. This is a project called Open Barriers, which is also in Toronto at the Bentway. This was a commission by the Bentway in Toronto. The Bentway is this really amazing public space that opened in 2018 that runs underneath the Gardiner Expressway, which is along the southern edge of the city, along Lake Ontario, and it's part of the Highline network. So here you can sort of see it's a linear park, but even in the winter they use this park for ice skating and all kinds of events underneath it. It's sort of similar to the under the elevated projects that we've seen in New York. And we were asked to be part of their safe and public space programming, which aims to broaden the definition of public safety to address this all happened during the lockdown actually, but it was designed to address the challenges of COVID health protocols and also the systemic inequities in public spaces like the Bentway. And so in particular, our prompt was to look at the design of safety infrastructures as it relates to access and also securitization. And so what we thought about was if infrastructure is typically designed with a singular functional purpose, we instead wanted to think about the capacity for infrastructure to operate double duty. So the Bentway, I think, perfectly illustrates that idea of something that's working double duty. An infrastructure that was created as a highway or an expressway that's being operated and very active on the top, but then now works double duty as a public space of gathering and events on its underside. And so since the late 20th century, many major cities have increasingly turned towards securitization and of course, privatization of public space. So harnessing design as a tool of protection and restriction. And this manifests itself in a whole slew of both visible and invisible ways that control and dictate how people can access the city. So things like spikes on windowsills to deter entry, armrests on benches to deter the homeless from sleeping, or even electronic modes of surveillance like CCTV cameras for traffic monitoring. And so safety infrastructures in cities like concrete jersey blocks, delineator posts, traffic drums, tend to exist in the background. And this is a diagram that we did of some sites in Toronto. So trying to think about how to bring some of these infrastructures to the foreground. And they're typically distributed as acts of control with little consideration for bodies or experience for that matter. So we thought, what if the affordances or really the underlying characteristics of these objects are reconsidered? Might there be an alternative way to engage them that could maybe benefit the public? So we developed two prototypes that explore the affordances of the concrete barrier for the Bentway to initiate a conversation around accessibility and also fundamentally infrastructure's value. We chose two sites that are within and adjacent to the Bentway to test out our ideas. And so here you can see this is the Bentway in the background. Our first prototype is called Play Stop. And we studied this typical site condition where concrete barriers are sprawled around as urban residue as a means to protect the site, which is not unusual in many cities. So Play Stop essentially uses the weight of the barriers as a kind of ballast to support both flexible and easily repeatable and expandable play structures using arches and horizontal members embedded into the barriers and hardware borrowed from scaffolding equipment. So this is a plan of Play Stop at this particular site, but it's quite flexible. And in this plan, the interior of the barriers becomes occupiable. And the system can then afford any number of activities, including tire swings, hammocks, monkey bars, lights for gathering, etc. And so the design, so this is the sort of after design. The design shifts the reading of the barriers really as an edge condition to an occupiable zone. And at the same time, the arches here are delineated with a kind of color, can also produce an identifiable threshold, both moving inside of the barriers towards the Bentway or from afar when the barriers align. And so how might the behaviors and habits of use that are affiliated with safety infrastructures maybe be disrupted or reconceived to reanimate these public spaces in more inclusive and participatory ways? And so this is the second prototype, and this is a site that's actually directly underneath the Bentway, and another kind of very typical condition of safety infrastructures where there's a very clear exterior boundary and an interior to the arrangement of the barriers themselves. This one is called Pollinator Rest Stop. And Pollinator Rest Stop rethinks the sidedness of the barriers to re-specify an interior and exterior of the object. So essentially looking at its profile to create a planter profile on one side of the barrier. And so if we zoom out of the site, the Bentway, which is where so the Bentway is linear, but our particular site along the Bentway is at this circle. It's essentially an intersection between the circulation of cars along the Gardner Expressway, as well as along a migratory corridor for monarch butterflies flying south, shown in the kind of larger stroked arrows. And so many profiles are possible with this kind of idea. But we decided on the planter profile to try to engage with a different scale of urban nature at the site and to sort of think about how to animate these latent urban environments and multi-species agents. And so the planting plan for the Pollinator Rest Stop blossoms in the spring, through the summer, and then through the fall, with this rotating set of species that both welcome and nourish the monarch butterflies along their migration path, along with the local pollinators. And so both Play Stop and Pollinator Rest Stop try to make a case for how these inanimate objects and artifacts in cities, like concrete barriers, can actually generate particular choreographies of movement and also produce mutualistic relationships between people or objects or other species. So this is the last project I'll present tonight. It's called New Public Hydrant, and it's a collaboration with an artist named Chris Wobkin, who's a good friend. And this project started in 2018, but it's been sort of this ongoing project. So we were commissioned by a curator named Jane Withers as part of a research and design exhibition at ADO, which was in Brooklyn and run by BMW Mini. And the exhibition asked, how can design help to address the drinking water crisis? And so we contributed to the Drink Local section with Studio Swine and also Ooze. And the Drink Local section asked, how can designers help reimagine ways to deliver water in cities as an alternative to single-use plastic bottles? So the starting point for this project was to look at everyday infrastructure, so similar to the concrete barriers, this time at fire hydrants in New York City. So while this is an everyday element that may seem small, infrastructures can never really be minor because they're part and connected to these larger systems and operate at multiple scales simultaneously. So for example, in this image, you see the individual element of the fire hydrant juxtaposed with this NYC GIS map of the kind of map of the hydrant infrastructural network. So for us, instead of seeing the hydrant as an emergency infrastructure, we wanted to reveal it instead as a source of clean drinking water. So to think about the idea of these environments that actually exist within and underneath the city and try to think about how to bring those to light. And New York is one of only 5 major cities in the whole country with a high enough water quality that doesn't require filtration, even though many people neglect that in favor of buying water bottles at bodegas or at the grocery store. And you know, New Yorkers are very lucky to have a watershed. So this is a watershed and water distribution map. Essentially, our water is coming from the Catskill Delaware watershed. And the drawings really sort of highlighting the infrastructural system of aqueducts, of reservoirs, of tunnels, bringing the water into New York City. But it's also trying to connect and make the point that, in fact, the water main that feeds potable water to our apartments and our houses is also connected to the fire hydrants that we use to put out our fires and wash our cars. So trying to show that in this diagram here. We are inspired by the New York City Department of Environmental Protection's Water on the Go program, which is essentially a collective water fountain that's hooked up to fire hydrants at events and at marathons during the summer. And our project actually came out of discussions with the Department of Environmental Protection about how to redesign these fountains. And they really wanted us to think about how to engage with the public in how do we think about drinking locally, especially from fire hydrants, and how can we think about shifting our perceptions of drinking locally. And so, you know, just to put this in context a little bit, it's about 1,000 times more expensive to drink bottled water than tap water. And it takes about 1.5 million barrels of oil to produce plastic water bottles in the US, which is enough to power 250,000 homes or 100,000 cars for that same year. And so the project for us really sort of tries to celebrate a city's civic resources, like fresh water in cities, as in Rome, where the infrastructure, the aqueducts are made visible with fountains that dot the city, for example, marking the end of those aqueducts with things like the Trevi Fountain. Similarly, in Rome, these are public water fountains called the Big Nose Fountain or the Nizzoni that make fresh water accessible to the public. And they have a bottle fill, but they also introduce these new kinds of gestures into the city themselves. So you can also use it as a water fountain if you plug the bottom of the nose, and then a kind of arched water comes up. And so there's a sort of new gesture that comes out of it. And so you can see this child trying to drink out of the Nizzoni fountain. And so we are inspired to imagine these new forms of public interactions and really wanted to test these in the public realm. And so we did 3 one-to-one interventions that are both prototypical and then also transportable. This was this former site of ADO, which unfortunately closed due to COVID, but it's in Greenpoint. And the 3 interventions are hydrant on tap, hydrant for all, and hydration space. And these are hydrant hacks. And they're meant to propose a gateway to reimagine your everyday experience with water infrastructure, kind of harkening back to the commons, like the role that the well or the water pump historically played, let's say, in a town square. And these are 3 of what could be many, many different prototypes. And they use the materials of plumbing and the logic of water infrastructure to create the pieces. So hydrant on tap is a bottle fill station that oscillates between everyday to emergency use. It's essentially a gooseneck head with a kind of slot machine arm to get your water on and off. We also developed a series of patent drawings for the project to both specify and illustrate the scale of the intervention of the prototypes. So for each of them, we have a plan drawing and then also an exploded drawing showing the parts. You wouldn't believe how different the fire hydrants are in New York City. So trying to just sort of think through what the variations are here. Hydrants for All is a multi-species water fountain for humans, for pets, and for birds. It's essentially 2 collective water fountains for people, and then there's a dog bowl at the bottom, and then a bird bath and bird fountain at the very top. This is that patent drawing, and we actually had a workshop with the Parks Department a summer or 2 ago, and the students there wanted us to have a pollinator fountain or some sort of an extension of the pollinator fountain at the top. And so it's just to say that I think this is the kind of project that can kind of be evolved over time in many different ways. This is the final prototype is called Hydration Space, which is an immersive microclimate and also sprinkler. This is testing out the installation. And so the idea was that the sprinkler head was designed to actually spray to create a kind of room around 1 or 2 people, essentially, as you could walk through. So you'd have a sort of urban room that could cool people down. The site of this particular one actually had 2 bollards next to it. So we imagined a kind of bollard bar where you could kind of, relax and refresh. And so if this video works, let's see. So the project is really a way of looking at the city to reconsider water infrastructure's capacity to work double duty towards designing a kind of collective civic space. And our thought was that could it be both functional and also pleasurable? So could we think about water infrastructure in ways that are not just towards a kind of engineering logic or kind of pragmatic logic, but one that it could actually have a different kind of charisma and add to the city. This is the dog Fela, who was a great model for us. And so, as I was saying, this has a kind of life of its own now. We actually have been working with a nonprofit out of Bennington College called Beyond Plastics. This was an installation we did during COVID last summer for hand washing stations, which were actually really in need. This is an installation in Red Hook that we did with Pioneer Works, and then also the Ready Center, which is the Resilience Education Training and Innovation Center. as part of New York City's Open Streets, Cool Streets program. And so this was installed on 9th Street and Henry Street for a good deal of the end of the summer. And so it's just to say that this is kind of an evolving project in a way. And so just to wrap up, I think this is just a selection of projects that I've been working on, and I think they're representative of some of the overarching concerns of the practice, and I would say it's a sort of evolving set of explorations. So thank you so much for having me.